Hello world, it's Angela, and this is my brother Nate,
What's up, guys?
and we are going to play with a new 3D web development tool slash framework called AFrame. And what's nice about AFrame is that it's VR first, but what's really cool about it, it's basically 3.js but with a DOM interface, so you can create a scene and you can make spheres or cubes or objects, and everything you do to them is, or the way that you specify where they are, what size, how they look, is all via attributes. So if you're familiar with D3 and SVG, right, in 2D graphics, we do a lot of describing how we want things to look via attributes, right? So we have a rectangle, and we describe its x and y position, its width and height. So what I want to do is, in this video, take us through making this simple bar chart. And it's got a little bit of interactivity. We'll play with that. But yeah, we'll generate cubes essentially for each piece of data we have using D3 in the way we normally do, and see how that works with AFrame. So I'm going to go ahead and copy paste just a little bit from here, just so we get the library going. We're not going to have an SVG this time. I'm going to delete all this boilerplate code. It's like a blank block. I'll say AFrame video. And then I'm also going to go ahead and copy paste some of this stuff here, and we'll take a look at what that does. But this is the scene. It goes in the body, and we basically get an empty canvas. We don't actually need this because we have here a camera that has look control. So once we put something, and we have a light, let's put something in here, a cube. And I think everything has defaults, so we should see a cube, although our camera is positioned very high in the Y. Well, let's try this out. Position equals 0, 0, 0. Let's make Y 1. Okay, so Y goes up. Z, let's make that -1, -2. So now we're pushing it further down out of the screen. We can put this back down here. Makes it basically a rectangle, right? The further out we go. So let's just put that there. And we can play with, I think, depth. So we can make it longer. So I think if we put this a little bit higher, we'll see the depth. Yeah.
That's deep.
Yeah. The height is in the Y direction. I think the width in the X direction. So we can put this out even further. See the perspective. So yeah, so we can play with those. I believe we can set a color. Oh, but our light is shining on it, so we have this ambient. We have two lights actually. And I was just playing around with having point and ambient. I don't really know this stuff yet. I know there's different kinds of lights that you can use to light up a 3D scene. There's things like materials, which allow you to make it sort of like a metal or a wood, or have textures and images and stuff like that, which I'm also not going to get into because I don't know how to do it yet. But
it's beyond the scope of this tutorial.
Yes. And beyond the scope of my knowledge. So. And there's a sky, which I think is just sort of like the background.
Is that this this kind of teal color?
Yeah, the teal here. So we set that here. We didn't change. It's more blue. And then the look controller, there's these on the camera. We have WASD controls. So when oops. When I move around, I can sort of see different sides of my box. So you're just kind of like walking around. And yeah, so what we really want to do though is make a bunch of cubes and position them as a bar chart. And then I think it's fun to sort of surround ourselves with the bars. Because one of the things I'm excited about this, I mean, you've been able to do 3D web stuff for a while with 3.js, besides it working really well with D3 from the DOM, is that the VR stuff is going to be a new way to experience 3D, right? That you can actually look around and use your spatial reasoning rather than just what's on a 2D screen. And I believe that will lead to new ways of getting a sense of things, right? A sense of space and size and patterns that uses more of our brain's built-in spatial reasoning than a 2D chart allows for.
Right.
Yeah.
Makes sense.
Although this 3D bar chart we're going to make is probably not the ideal way to experience that, but it serves as a really good way to introduce technically how we can use D3. And we're just doing the simplest thing we can do in a 2D chart and moving into 3D and seeing what that takes. And it definitely opens up new challenges.
Sounds good.
Yeah. So I'm going to go ahead and just kind of copy a little bit more, some fake data here, so we don't have to type it out. And then normally we would just grab an SVG element, but I'm going to call it a scene, so I'm going to select the A scene. And since this is a D3 selector, right, CSS selector, I'm just selecting this, which is in the DOM. And
that's really convenient.
Yes. And then I will, yeah, and it's really cool because it just matches the way we do SVG exactly. And then just like we would do with a bunch of rectangles, I'm going to select a lot of A cubes, and I'm going to select all the ones that have class bar, which there are none yet. So this one won't get in the way of the selection, basically. And I'm going to give it our data, and let's say I'm going to save this as cubes, and then I'll enter my cubes and append a cube for every one that doesn't exist yet and give it a class bar. So now I should have a bunch of cubes, and now I can set their attributes. And so I'll start with their position, just like I do in SVG, and maybe I'll return for a second. Well, let's do it like this. I know I'm going to need an X, a Y, and a Z. And I think what I did last, what we played with IQ, and move it back into the screen so that, I guess looking at the camera is this way. And we just compose a string. So now we have a bunch of cubes that are all in this exact same position. If I were to do I here, they're all lined up. I can do I times 2 maybe. It's that way.
So wait, why does I line them up like that?
Because when you're using D3 and you do one of these functions, right? Mm-hmm. You get D and I, and D is the data element. So for each element in the array that is now bound to one of these cubes.
Right. That's when you did the select all data.
Exactly. Mm-hmm. Yeah. So this is the binding part to make this variable hold basically a D3 selection, which is kind of a collection of DOM elements mixed with their data. And the enter part is because the thing that's kind of confusing about selections is that you can select things that don't exist yet.
Right.
But well, you can select. You're sort of always selecting DOM elements, but you can select DOM elements that don't exist yet, and you do that by specifying more data, right? And so we have a big list of data and no DOM elements. So the enter is like, okay, well, in that case that we don't have a DOM element, let me tell you what to do, and I'm going to tell you to create a new one. Right. And that's what this append part is.
I see.
And then I'm also going to add the class bar.
So it's enter and append working together that actually sort of adds those new SVG.
Exactly.
Okay.
And so then I can show it here. So in my scene, I have all the stuff I made manually, right? Like the original cube, the lights. But then here's all the bar cubes. And you can see that their position, the x coordinate is 0, 2, 4, 6, 8, 10. That is because this A cube, that bar, here's the data that's bound to each one. But the I is the index in the array. So you count 0, 1, 2, 3 going on.
Awesome.
And so we're just saying, oh, make the x coordinate 2 times whatever the index is. So they're all spreading on the x-axis. If I change this to, let's say I put that back to 0 and I put this here, then they're all going to go in the y direction and stack up like that. And then, of course, if I did plot, let's say minus I times 2, then they're going to do this like staircase thing.
That's awesome. And so if you did something with D, they'd kind of be all over the place, right? Since it's...
Yeah, so but we want to use D because we want to make, let's say we want to make them all, their height all as function of their values, right? So let's actually do that next. We'll just leave it like this for now because why not? And so let's say we return D for their height. The problem is that was kind of cool already.
Yeah, it's pretty neat.
That when you use D, right, your numbers could be so totally different scale. Like if we were talking about the world economy, those could be like billions, right? And so these would just go like way crazy. So one of the first things you want to do with, or learn with D3 as well, and that works really well for drawing stuff in any case, is I'm going to make a height scale. And so there's this idea of making a linear scale in D3. And you give it a domain and a range. And the domain will be like your data's domain. So you make it from 0 to the biggest number in your data. And we can just use d3.max on our data because, and that will tell us the max. And then the range will be what you want it to be in screen coordinates. So here, the value of 1, like a cube of height 1, is pretty big, right? So let's just make this like 5 or so. So now if we zoom, oh, well, we didn't change it yet. We can also change our camera position by, this is a nice trick. By wrapping this with an entity. So an entity is kind of like a G in SVG, like a group thing, where it can kind of hold a lot of stuff, and you can supply plugins to it. Let's see. So I'll move this over, the other way. And that way, and we can even rotation. So we can rotate around X, Y, and Z. And so I'm going to rotate 30 degrees around Y, or negative 30. What if I do negative 40? Yeah, so I'm sort of rotating the camera this way and moving out, move further out. And so this is kind of interesting because in 2D, right, like everything is just in this nice square, right? And here, there's all kinds of stuff that can happen. And, even just checking that we're seeing the right thing requires thinking about 3 degrees of freedom in terms of position and rotation. And
right.
So it's useful to, practice it.
It's just brain training.
Brain training, yeah. And it does make for an interesting challenge in terms of, dealing with all these new dimensions. So anyway, we wanted to scale the value. So here, what this Hscale variable holds is actually a function. There's a common D3 pattern. We call this function, it generates a function, and then we set the settings on it, telling it what the domain and range are. And now we can call it, and so now our variables are properly scaled. Exactly. And so this gets kind of interesting. So I'm sending them back into Z. Maybe I'll do this in the X direction again. I'll move my camera back to 0 maybe. But it's because they're all sort of positioned from the center of the cube. So rather than the top left, like in SVG.
Right. So
one thing we can do is, I think, add or subtract Hscale of D over 2 so that they sort of line up. So that will put them, that will place them from the bottom, and I think if we subtract this, oh, it flips them. So yeah, we'll just do that.
So I don't really get how that, why that lined them up from the bottom.
So because they're all being centered on, you know, the width, or I mean on the height, right? So a big one, their center is lining up, but I want them to be drawn from, like, so that the bottom all lines up. So I'm adding to the Y however much half of the height is. So if what I should do is I'm going to make this original cube be 0, 0. It's going to be in the same plane as them. Wait, -4, Z -4. And the depth will be 1. The height will be something small. And yeah, so it's on the 0, 0, you know, x0, y0, and the width will be like 50 or something. Or we'll just make it 100, just send it way out. So that cube is sort of the baseline of our thing, right? And so when we just had 0 here, the baseline went through the middle of our cube. So we're trying to move each cube halfway up, half of its height up. And its height is determined by the scale function, right?
Right.
So I'm dividing the height by 2 to move it up.
Right. So it's kind of, I mean, it just defaults, each cube defaults to be aligned, or the position is based on the center of it, right? So when you wanted to line it up on the bottom, you had to divide it by 2.
Exactly.
Yeah, I get that.
Exactly. Yeah. So, I mean, this is already a basic bar chart, right? And we can already see why, in general, a 3D bar chart would be bad, is because, like, this, our biggest value, if you just look at the array, is about 200, and that's all the way down here, looks smaller than this value over here, which is 20 or 30 or something, right? So our eyes are not going to be able to compare, or our brain is not going to be able to easily compare these values, which is what a bar chart is usually doing. But what's cool about this is that you can sort of get up close and personal, and if these things represented, you know, something, now this one definitely feels way bigger than this one, right? So there's a different experience available here. You have to look up to see the top of that one, right? And that, I think there's some rich opportunities to, you know, work with and explore in terms of giving people a sense of quantities. And, you know, this is just getting it to show up on the screen. I think the final thing we can do is try to wrap it around us. And I think so already we're at a place, let me just call this, one. I'll probably make a few videos showing some of the stuff I've learned playing with this. But we're already in a place where we basically have taken what would normally be a 2D bar chart and turned it into 3D.
Mm-hmm.
So, but one of the interesting things to start thinking about in 3D is, okay, so my camera starts at 0, 0, 0, right? I'm in the middle, and I want these bars to go around me so I can kind of look around. And when you have a headset, or if you use the iPhone or Android to load this page, you can actually look around.
Huh.
Although it's still got some, AFrame still has some bugs they're working on. It's a very new library with the phone support, but it works. So I want to look around. I want to capture that that feeling of being surrounded by the data. So I can use actually a bit of math to basically lay out my bars, their x and z positions. So x is this way and z is this way. I want them to be in a circle, right? And so, normally in 2D you have x and y, and we can just use a little bit of trigonometry to say, I want them on a circle of a radius of, let's say, 10 or so, right, to go around me. So I'm going to define my radius to be 10, and I'm going to need an angle, because we're basically, for each data point, we're going to split up the circle into little slices so that we can place our bars. So we need an angle for each one. So I can do I divided by 2 divided by math dot pi. So that's I divided by 2 pi, right? So 2 pi is 360 degrees, right?
Well, wait, you're dividing 2 by pi.
Oh, sorry. This is the way because it's the operations. It would just be I divided by 2 and I divided by math.pi is how that would be in the...
Oh, I see.
So this is the equivalent, right? So I'll just put it like this to be a little more clear. So this will give us some amount of degrees, basically, or radians, because the trigonometry functions we want to use. Basically, we use cosine and sine, right? So x is the cosine of your angle, and then y is the sine of your angle, if this is your angle. But since we're not doing x and y, we're doing x and z, we're going to use z will be the cosine of the angle. So we can do radius times math, I meant sine, theta, and then x will be radius times math cosine theta. And so this gives us something strange, almost like a square, it seems. So one thing I can, that's crazy. So let's move the camera up in the Y so we can look down on things. No, it's sort of circular. It's just half a circle. Oh, right. So this needs to be this shouldn't be divided by that. It should be I divided by data dot length. There we go. So now we look down, we get a circle. Sweet. So if we put the camera back down, 0, 0, and let's get rid of our little cube, we have squares all around us. Now the problem is, if we go up, or one sort of problem with this is that all the squares are sort of, sitting in their square. So when you're looking around at them, like the one over here, you're seeing the side of it instead of the front. And so one thing that might be nice is to rotate them to all be facing the center, right?
Right.
So let's do that real quick, and I think this would be like the last piece of the puzzle, what we call it. I'm also going to rotate on the camera on the x-axis.
Excuse me. Thank you.
So I can turn my camera down a little bit. So by default, I'm just looking down and over, I guess. If I change this back to 0, we'll be looking at the beginning. All right, so I want to rotate each cube so that it's around its y-axis, right? Because y goes up and down, so I want to rotate around that a little bit. And so, but the rotation takes stuff in degrees. We also want an x, y, z, and I'm just going to copy this. So we want to rotate around the y. So I want to do something like, basically again, I divided by data.length and 360 times that. Okay. You pet him or something?
Come here, bud.
He's on his last legs, unfortunately. So I have some weird rotations going on here. Come here, Topia. Come on. Oh. I think I was rotating them the wrong way. So I'm rotating them negative. So now they're actually nicely circular. So basically for each little slice, I'm rotating it the opposite of the way we're going, so that we're rotating this way. Instead of rotating this way, we rotate with it. It's, yeah. It's sort of, this is one of those things you want to play with yourself, because this just looks obviously wrong.
Right.
And then just changing it to negative makes it right, which is kind of weird. But we know that we want to rotate it some slice. Well, you can also think of it, the very first one doesn't need to be rotated because you're looking right at it, right? And 90 degrees, when you've gone around 90 degrees, that cube should have rotated 90 degrees, right? But actually it needs to rotate. You're rotating to the right is positive. Rotating that 90 degrees would actually rotate it, so you see the back of the cube, so you need to rotate it negative 90 degrees to have you see the front of it. When you get 180, you want that cube to be 180, right? So that's how you can kind of think about it from the cases where you know what it should be, and you don't have to do weird math in your head. Like 90 degrees, 180.
Right, because it actually needs to sort of compensate for the rotation of the circle.
Right.
Yeah, and kind of exactly the opposite of it.
Right.
That makes sense.
And thinking about it at 90 degrees is 90, 180, 270 can help, because you know that the cube, like, you can imagine in your head easier.
Right.
Yeah, so we put the camera back down and not look at the ground. So this brings up, that's actually some interesting stuff too, is that it'd be nice to have some indication by default of if you're looking, or that the fact that there's something you should look up or down. Someone, when I originally tweeted this out, they're like, oh, I was looking at my phone, but my phone was facing down, so I didn't see anything. So until I, realized I needed to look around. So it's gonna be a new thing, where, like, are people really gonna be on the subway and just be like trying to see the thing that you made?
Right. You have to start getting phones that project, images and a hologram or something.
Yeah, that'd be nice. So yeah, you can just walk around, see your little DataViz Stonehenge thing. So I'm gonna save this, and yeah, there's very little code to start messing with a 3D environment. And when you start taking a look at some of the cool stuff you can do, there's like this idea of fog. Oh wait, where's the spheres and fog? You can actually have things look far away and fade out. So I'm really looking forward to playing with some of these techniques for creating experiences and giving people new insights. This one's taking a while to load. Oh, there we go. This one's pretty cool. And it's really trippy when you're wearing the headset.
I bet.
It's going a little slow, I think, because I'm also recording the screen right now.
Yeah, it sounds like
yeah, it's
computer's revving up.
Hitting the fan. But yeah, check out AFrame. Check out, play with this for yourself. I think it's pretty exciting to be able to transfer all the stuff that I've been working on in 2D into 3D right away and be able to play with this web VR stuff. So I think, VR is going to be pretty crazy with the phones supporting it already, and then the Oculus Rift and those kind of goggles coming out.
Yeah.
Giving like pretty intense experiences. I think it's supposed to be a fun time. All right. Well, thanks for helping.
Awesome. Thanks for having me. It's been a pleasure.
See y'all later.